We're solving systems of equations by elimination. We've learned two other methods so far. Okay, the first day we did graphing, right? We were graphing lines and seeing where the two lines touch. Okay, that was our first method. When's the best time to use that method? What form do we want those equations in? Not standard. The y equals slope-intercept. Okay, so when we have two slope-intercept form equations, graphing is the best way to go, right? Okay, then what did we learn not yesterday, but the day before? Substitution. When is substitution the best to use? So they can be in standard form. Wouldn't it be nice to have one in standard form and one in slope-intercept form? You want a letter by itself. So anytime you have a coefficient of 1 or something alone, a letter alone, that's the best time to use substitution, right? Now, look at this problem. Do you think substitution would be fun here? No, because there's all these numbers. There's nothing with a coefficient of 1, so we'd have to like solve and plug in fractions, and it wouldn't be that much fun, I promise. Okay, so we're learning a third method. It's called elimination. What does it mean to eliminate? To take away, to cancel, to all of the above, okay? I also want you to realize this is kind of a mix of elimination and substitution, because you use elimination to find your first letter and then you substitute to find your second letter. So it's kind of a mixture, okay? But it's like that last step of substitution where you just plug in and solve, okay? So that's what we're learning today. Now, there's a couple things you need to know to learn this. So who knows what a zero pair is? What's a zero pair? So it's two terms that cancel to make zero. So I'm going to show you an example. That's really beautiful handwriting, by the way. Two terms that cancel to make zero. I promise that's what it says. So example, what term would cancel a positive 8x? A negative 8x. So guess what? Those are zero pairs. Because if you put them together, what do they make? Zero. Did you see what I'm saying? They're the same term. What's the only difference? A positive versus a negative. Okay? That is the only difference in a zero pair. One of them will be positive, one of them will be negative. Other than that, they're equal, right? Okay, so that's the big thing we need to know. I also want you to know that I call elimination big addition sometimes. Probably all the time. Because elimination is you create like a elementary aged vertical math problem, right? Do you remember those? Like a number over a number with a line underneath. You remember that? That's what we're about to create. So if you don't remember, I promise you will in a minute. Okay? It's like that elementary vertical math. Okay? And I call it big addition because you're adding like 6 terms. So it's a lot. Well, not a lot. I don't know. Okay, so let's get started. Now, you want these in standard form. Technically, they could be in slope-intercept form, but would you really want to do all this math work if you could just graph them? No. So if they're in slope-intercept form, which way are you going to do it? You're going to graph them, right? Okay, but if they're in standard form, that's the best method here, is when you have two standard form equations. Okay, so let's look at these. So you want either your x's or y's to be a zero pair. Are either of those zero pairs yet? No, so we can make them become zero pairs. Okay, so this is how you want to think about it. Can 3 turn into 9? So right away we know x's would be an easy one. But can 2 turn into 5? No, so we don't want to do y's. Because if we do y's, we have to multiply both equations, and that's more work than we want to do. We also know one needs to be positive and the other needs to be negative. So if this is a positive 9, what do I want this top one to be? What would I multiply 3x by to become negative 9? Negative 3. So I'm going to multiply that whole equation by negative 3 because that's what keeps the equation equal, right? I have to do it to everything or I've changed the equation. Okay? So what is negative 3x times 3x? And what's negative 3 times 2y? Negative 6y, remember you're multiplying. Negative 3 times 14, I know that a lot of the calculators aren't on the desks, so negative 3 times 14 is negative 42. Okay, now since I did it to all of the terms, this equation is still the same equation, it's just got bigger numbers. Okay, so I'm going to bring down that other one, 9x minus 5y equals 31. And this is why I call it big addition, because I'm going to set up a vertical big addition math problem. I'm probably the only teacher in the world that calls it big addition, so I don't know why. It's just what makes me remember it. When I think of elimination, this is what I think of, not elimination. I don't know. Okay, so now we add each term. So what's negative 9x plus 9x? 0. That's what we wanted it to be, right? What's negative 6y plus negative 5y? Negative 11y. Remember, if I take 6y and then I take 5 more y's, then I took 11 from you, okay? Equals, and then negative 42 plus 31 is negative 11. Now, don't I only have one term left? So can I solve for, or not term, variable? So can I solve for that variable? So how do I solve for y? Divide by negative 11. What's negative 11 divided by negative 11? Positive 1. Guess what? That's half my answer. So we know that our solutions here are an x comma y solution, right? And so I know that y is 1. Now this is where it can, like, it's no longer elimination, now it's substitution. What did we do yesterday? Do you have a question, Joey?
Oh no, I get it.
Okay, you sure?
Yeah.
Okay. So what did we do yesterday after we got one variable? We plugged it in. We substituted it in. Now, do you think it matters which equation you substitute it into? No, I always pick the one with smaller numbers. It's just me. Okay, so I would probably pick the top one. So I have 3x plus 2y equals 14. And I know that if y is 1, I can replace y with 1. Okay? So knowing that, I get 3x plus 2 times 1 equals 14. What is 2 times 1? 2. So this ends up being 3x plus 2 equals 14. Now what? Subtract 2. And I get 3x equals 12. Last step. Divide by what? And what does x equal? There's my answer. Whoop. Now, what kind of solution is this? Huh? It's a point, but what kind of system? Sorry. Not solution. Kind of system. Independent and consistent. Why is it independent? How many solutions are there? 1. That's why it's independent, because there's only one solution. And it's consistent because it has a solution. Okay? Now, do you think you can check your work still just using your calculator? Yeah. 3 times x, which is 4, plus 2 times y, which is 1, should equal 14, did it? Did it work? Yeah. Now, am I supposed to check it in one equation or both? Both. Remember, it has to satisfy both. 9 times 4 minus 5 times 1 should equal 31. Did it work? Yes, so my solution is correct. Okay? Any questions with that? Cool. Let's try number 2. Okay, what's our first step? What did we want to create first? a zero pair. So what do we want to do to make a zero pair here? The opposite. Now, can you turn a 6 into an 8? No. Can you turn a 3 into a 5? No. So technically on this one, we're going to have to multiply both equations. Okay? Now, I always pick my smaller numbers because it doesn't matter if you cancel x or y. So I just pick the smaller numbers because they're usually easier to figure out. So which ones would you pick here, x's or y's? Y's. What can both of those numbers turn into? 15. It's just quicker to notice. What would both of the x's turn into? See, we got an answer from y's first, so do your y's. Okay, do whatever comes to you fastest. Okay, so we are going to multiply both equations. So we're going to turn this into 15y. What am I going to multiply it by? 5. So this first equation is going to be multiplied by 5. Now, what would I multiply the bottom equation by? -3. Why a negative? Because we want to make the zero pair. And right now they're both positive. So we need one of them to become negative. Okay? Any questions with why we chose those numbers? Yes? Yeah. So we decided it didn't matter which one. You can cancel x's, you can cancel y's. But we noticed first that the y's can both turn into 15, right? If we multiply. But both of them are positive, and I need them to be a zero pair, which remember means the same, but one being negative, one being positive, right? So I'm going to multiply the top equation by 5, because that will make this a positive 15y. And the bottom equation by -3, because that will make this a negative 15y. Okay, and that will make it a zero pair, so I can solve for x, right? Okay, so knowing that, what's 5 times 8x? What's 5 times 3y? And 5 times 41. It's going to be a big number. 205. Okay. What's -3 times 6x? -18x. What's -3 times 5y? And then another big number, -3 times 39, error, is -117. Now what do I do? So we made the zero pairs. That was our first step. What's my second step? To add. We're going to do our big addition. Okay, so what's 40x plus -18x? Well, 40 plus -18 is 22. 15y plus -15y, 0, equals 205 plus -117. Is that what it was? Yeah. Is 88. Now that we have one variable, what's our next step? To solve, to divide. Okay, so I'm going to divide both sides by 22. And I get x equals what? 4. So half of my solution, it's the x side, so x is 4. And now what's my last step? Plug it in to substitute. Okay, doesn't matter which equation. Now, I always pick one of the originals. Okay, so I'm just going to pick the bottom one because those numbers look, I guess they're both, I don't know. Anyways, it's just the one I picked. 6x plus 5y equals 39. So because I know x is 4, I'm going to replace x with 4. So I get 6 times 4 plus 5y equals 39. What's 6 times 4? Now what? Subtract 24 from both sides, and I get 5y equals what? Divide both sides by 5, and I get y equals 3. So my solution is 4, 3. Again, this is independent and consistent. I'm not going to write it out this time. I wrote it out the first time just to remind you what it stands for. So again, we can check our work. I'll move it over here so those of you still writing can write. And we have our first equation is 8 times 4, which is x, plus 3 times y, which is 3. And this should equal what? Did it work? Okay, and then 6 times 4 plus 5 times 3 should equal 39. Did it work? Yes, so we got the right answer. Any questions so far? Okay, let's look at number 3. What are we going to do? We need to make a zero pair. Okay, so what do you want to cancel, x's or y's?
I mean, why?
It doesn't really matter because we're going to have to multiply both equations. So what can the x's or y's both become? X's can both become 30. Okay, so let's do x's. Okay, what would I multiply the first equation by? And what am I going to multiply the second equation by? Negative 3. Good job. Okay, so knowing that, 2 times 15x is 30x. 2 times negative 12y is negative 24y. 2 times 18 is 36. Okay, negative 3 times 10x is what? Negative 3 times negative 8y, positive 24y. And negative 3 times 12 is negative 36.
So everything cancels out.
Everything cancels out. You're exactly right. So when we do our big addition, 0, 0, 0. So this ends up being 0 equals 0. Is that true or false? True. 0 does equal 0. If I have none and you have none, we're equal, right? So this is true. So what do you think the answer is? Infinitely many solutions. I don't know if I ever spell infinite right. Shouldn't that be an I? With another I? Man, I'm doing really good today. Infinitely many solutions. This is why I teach you math. You don't want me in your English class. Okay, because we would all be terrible at life. Okay. IMS is another way to say this. And what kind of solution is a system is this then? Say what'd you say? Dependent. So this is dependent. And it's still consistent. Why? Because it has solutions, or a solution, at least one. Okay? It's dependent because all the solutions are solution. Everything's a solution. But it's consistent because there is a solution. Okay? What if we would have gotten 0 equals 5? What would the answer be? No solution, and it would be inconsistent. Does that make sense? Okay. So, if you look at number 4, what method would you pick here? If you had to pick a method, graphing, substitution, or elimination, what would you pick on this one? I would pick substitution. Why would we pick substitution?
Because y had that 1.
Because can't you get y by itself super simple and just plug in?
Yeah.
Okay. I know we're doing elimination today, so we're going to solve it with elimination just to show you that even if they're not all in standard form, you can put them there. But if we were real life doing this, would we really make more work for ourselves, or would we just do easy substitution? Yeah, you wouldn't make it harder. Okay? But that's, what I like to do. So we're going to put them both in standard form. Okay? What do I need to move here to get x and y on the same side? The y, right? Can I just subtract y from both sides? Minus y, and I'm going to rewrite it but flipped, and I get 4x minus y equals 5. So all I did just now was rearrange that top equation. Okay? What about the bottom equation? X and y are already on the same side, but are they in the right order? No. So what do we want to do? Just flip them. What kind of 8 is that? Negative. So it needs to stay a negative 8. And that's a positive 3y, so it needs to stay a positive 3y, and it equals 7. Now is it set up for elimination? Yes. What do we want to cancel? X's or y's? X, y, x.
4 can turn into 8.
4 can turn into 8. Here's my question. Who thought y's first? Nobody? Okay, technically, could you multiply the top equation by 3 and cancel the y's? So I want you to realize there are times where you can cancel either. It does not matter which one you cancel. No matter what you do, as long as you do it right, you'll get the same answer. Okay, so we'll cancel the x's because that's what y'all noticed. And what do we multiply that top equation by? By what? 2. 2 times 4x is 8x. 2 times negative y is, and 2 times 5. Okay, I'm going to cross that out and just use the 2 I already have written. Wrote, whatever. What is my 0 pair here?
8.
The x's, the 8's. Okay, what's 3y plus negative 2y?
1y positive.
Just y, right? And what's 7 plus 10?
-3.
Or 17. What? Okay, so we know x comma y is 17. It's okay, Marquise, we forgive you. Now what? Plug it in. Now, I want you to realize I always like to plug it into the original equations, not the ones we changed. Okay? It's just how I do it. So which equation would you pick? Which one do you think is the easiest? The first one, okay? So we have y plus 5 equals 4x. That's the original first equation. Well, if y equals 17, I can replace y with 17, and I get 17 plus 5 equals 4x. What's 17 plus 5? Why did I write 45? 4x. Sorry, y'all. So this gives me 22 equals 4x. And now how do I get x by itself? Divide by 4. It's not pretty. But is that okay? Yeah. Okay, so what's my rule if you're going to write it as a decimal? It has to be a pretty decimal. It can't be a repeating decimal or like 12 decimals long or places long, okay? So if we divide 22 divided by 4, is it a pretty decimal? Yeah, 5.5. So if you want to tell me x equals 5.5, that's fine. But be careful. What if your answer choice had 11 over 2? Is that the same thing? Now, what if you didn't know it was the same thing? And you were on a multiple choice test and you got 5.5 and you don't know what that is as a fraction? Could you literally go to your answer choices and just divide the fractions and realize that 11 over 2 is the same thing? Does that make sense? Okay. I'm going to put 11 over 2. If you want to put 5.5, that is totally fine. My comma is not in the middle. Any questions with that? Okay. Okay, y'all are going to love the one on the back. Are y'all ready for this? Are you ready? It is so pretty.
Very ugly.
So much fun. I know. Y'all are so excited. I think if I looked at this problem on a test, I'd be like, we're just going to fail. Okay, it's fine. I can promise you this is not on your test. Okay, one like this is not on your test. No. Y'all have an extra credit opportunity on Friday. We're testing after break, which sucks, but we're going to have 2 full review days, and I will go over examples of each during those days. Anyways, what's your first step here? What do you want to get rid of the most? Before we even talk about letters. What's the ugly part of this? The fractions. Can we get rid of fractions?
Yes.
Yeah. Can we make their denominators match and cancel them? Yes. So that's what we're going to do. Can 50, 25, and 100 turn into something the same? What can they all turn into? 100. 50 times what is 100? So remember, multiply top and bottom by 2. 25 times what is 100? 4. Okay, and then this is already 100, so there's nothing we need to do for it. So we end up getting 2x over 100 plus 4y over 100 equals 9 over 100. When the denominators match, they cancel because how to get rid of division? Multiplication. So if I technically multiply this whole thing by 100, doesn't that just cancel the denominators? And we get 2x plus 4y equals 9. Doesn't that look so much better? Yeah. So much better. So remember, anytime your denominators match, cross them out. Okay? Now, remember though, they have to match all the way across. So like on this one, we can't just cross out the 10s because that's a 5. Okay? You have to be able to cancel all of them or none of them. Okay? So what can we turn a 10 and a 5 into? 10. Can't I just multiply this one by 2 and then not all of them will match? Yeah, so we end up getting 1x over 10 minus 3 over 10 equals negative 8 over 10. If we multiply the whole thing by 10, what happens? The denominators cancel, and we get 1x minus 3y equals negative 8. Now does it look like something we can manage? Yeah. Because could you technically do big addition up here? I'm sure you could. But it might not be pretty. Okay? You'd be like multiplying by fractions and making bigger fractions, and it would be really gross. So I don't recommend it. Okay? So what do we want to eliminate? We need to make a zero pair. X's, why? What kind of 2? Negative 2. Okay? Because remember, one has to be positive and one has to be negative. So this becomes negative 2x plus 6y, remember we're multiplying, plus or equals positive 16. Everybody okay with how I got that? And then I'm just going to rewrite the other equation. And now we're going to do elimination or big addition. This zeroes out. I get 6y plus 4y equals 10y. 16 plus 9 is what? Okay. Next step. Or could you also get 5 over 2?
Yes.
Yes. Okay, I typically tell you to plug in for substitution to the original. Do any of us really want to multiply any of those originals? No. So this is one of those special cases where you ignore that rule. We are not looking at those anymore. We're pretending these are our originals, okay? So which one do you want to plug into? The first one. Okay, you want to know why I think the first one? Because I know this 4 will cancel that fraction, okay? But a 3 will not cancel the fraction. So that's just me. If you don't notice that, that's fine. You'll still get the same answer. So we're going to do 2x plus 4y equals 9. And we're going to replace y with 2.5 or 5 over 2, doesn't matter. Okay, and we get 2x plus 4 times 2.5 equals 9. What's 4 times 2.5? 10. So 2x plus 10 equals 9. Now what? Minus 10 minus 10. I get 2x equals negative 1. Divide by 2, x equals negative a half. This is independent and consistent. One more and then I'm done talking. And I promise you it looks nothing like that one. Okay? It's just a word problem. Your favorite, right? I see the excitement in all of your faces. Okay, the Miller and Benson family went to a theme park. The Millers bought 6 tickets and 15 child tickets for $423. The Bensons bought 5 adult tickets and 9 child tickets for $293. Find the cost of each type of ticket. So freeze, read that last sentence again. Find the cost of each type of ticket. What are we trying to find? The cost of adults and the cost of child. So those are our 2 unknowns. What do you think we want A to be? Adults. So this is cost of adults. What do you think C represents? Cost of child. Technically, if you wanted, you could flip those letters, but that would get really confusing. Okay? So I want you to remember, when I'm asking you to define your variables on your practice problems, that's what I'm asking. What does your letters you're putting in your equation represent? Okay? And you can always find that answer in the question. Okay? So knowing that, let's look at the Millers. The Millers bought 6 adult tickets. So they bought 6 tickets costing A. We don't know how much. Plus, they also bought 15 child tickets costing C, because we don't know how much. And they spent a total of $423. They need less children and adults. Okay? I don't know if I would ever be brave enough to take that many kids to a theme park. Okay, and then it says the Bensons bought 5 adult tickets plus 9 child tickets, and they sold $293. Or they spent, sorry, $293. Now is this something we can solve? So what do we want to cancel? A's or C's? What do we want to make a 0 pair? A. What can 6 and 5 both turn into? 30. Okay, what are we going to multiply the first equation by? 5. Okay, and what are we going to multiply the second equation by? Negative 6. Good job. Okay, what do you notice, though? Aren't they the same number, just flipped? That will always work. So if you ever can't figure out what the 0 pair is, you can literally just multiply them by each other. Okay? So 5 times 6A is 30A. 5 times 15C is 75C. 5 times 423 is 2115. Negative 6 times 5A is negative 30A. Negative 6 times 9C is negative 54C. And negative 6 times 293 is negative 1758. Now what? Big addition. 0 pair cancels. 75 plus negative 54 is 21C equals 2115 plus negative 1758 gives me 357. What's my last step here? Divide by 21. And I get 357 divided by 21 is 17. So a child ticket costs how much? $17. That's a really small dollar sign, I promise. Last step. And then I'll quit talking. Plug it in. Does it matter which one? No, I'm going to plug it into the second one. 5A plus 9C equals 293. So I know that C is 17, so I'm going to replace C with 17. 5A plus 9 times 17 equals 293. Nine times 17 is 173. 53. Goodness gracious. I'm going to subtract 153 from both sides. Get 5A equals 140. Now what? Divide by 5. And I get A equals 28. So what's the answer to my question? Word problems get word answers. Okay, I'm going to show you the practice has how many problems? 3. And you only have to solve 2 of them. Okay, just like yesterday's practice, if you solve the first one, I will give you more points. Are y'all done writing this down? Okay, there is one thing I want to write on the front. Okay, and that's your steps. What was our first step? Make 0 pairs. What did we do after we made a 0 pair? We did our big addition. We eliminated, right? And solve. That's kind of all one step. Big addition and solve. Okay, and then what was our last step? Substitute and solve again. Okay, any questions with that? Oop, might help if you can see what I wrote. Okay,